The purpose for this lab is to create an IPSec site-to-site VPN between these two head-end devices. That's the one from AfriLink Network Consult and Euromat. So we are going to create a VPN, IPSec VPN between these two sites so that these two pieces can communicate using their private IP addresses. So we are going to assign this PC here 10.10, and this one will also be 10.40. So let's go through the question. The question says, AfriLink Network Consult has a working IPSec VPN connection with Euromat. Recently, AfriLink wanted to have access to linkedin.com. So network address translation was configured on their edge router R1 to translate their private address 192.168.10.0/27 to the public address of 203.10.0.1. After the network address translation configs on R1, the VPN channel with Euromat ceased. Identify and rectify the problem. But first, do this. We have to configure an IPSec channel between the AfriLink and Euromat head-end routers. Then we ensure there is a connection between their private addresses by putting them on a continuous ping. So let's do that. But before we do it, I'm going to pause the video to configure the IP addresses on the interfaces of the routers. So on this router over here, G0/1, I'm going to assign 10.1. And this will also be 0.1, 0.2, here, 10.1. And on this PC, that is the IP address, and it's a /24. So the default gateway is going to be 102.108.174.10.1. Then I'm going to assign 10.1 to this interface of the internet router and 10.2 here. So that is what I'm going to do right now. So let me pause the video. So now I'm done configuring the IP addresses on the interfaces for all the nodes. So what I'm going to do next is to configure a default route pointing to the ISP on both head-end devices. So on this AfriLink router R1, I'm going to configure a default route and point it to .2. I'm going to do the same here on R2, so R1 and R2. Okay. Doing the same on R3. Pointing it to 72.160.10.1. 72.160.10.1. So now that we are done with the default route configuration, let's see if the two head-end devices can communicate with each other. So I'm going to do some things. On R1, I'm going to ping this interface here, 72.160.10.2. R1. Yeah, there's communication. So as you can see, the edge routers are communicating with each other. The next step is to configure side-to-side VPN between these two devices. So we are going to start with IPSec phase 1. IPSec phase 1. For phase 1, our encryption algorithm will be AES 256. Authentication, we are going to use pre-share. And Diffie-Hellman group 2. So our key, our pre-share key is going to be test 1, 2, 3. So these are the phase 1 parameters, and we are going to do those configurations on both R1 and R2, R3, sorry. R1 and R3 here. All right, so let's go ahead. R1. Encryption, AES 256. Authentication, pre-share. Diffie-Hellman group 2. Then we exit. So crypto ISACAN key. We're using test 1, 2, 3. And we are pointing it to the remote address of 72.160.10.2. Let me be sure. Over here we have 72.160.10.2. So we are right on R1. All right, so let's do the same on R3. Did we name R3? Let's see. Okay, so let's give R3 a host name so we know where we are on which router we are on. R3. Host name Euromat. Crypto ISACAM policy 10. Encryption AES 256. Auth pre-share group 2 exit crypto ISACAM key test 1 2 3. All right, so test 1 2 3. Address and the remote address of Afrelink is 203.10.0.1. 203.10.0.1. Let's save. Let's save this as well. So now we are done with phase 1. Phase 2. We are going to combine authentication header and ESP. So for the phase 2, IPSec phase 2, for the authentication header, we are using SHA and HMC. Then for the ESP, we use AES 256. Just that. So let's go do this configuration on both R1 and R3. So first R1, crypto IPSec transform set. Let's call it Afrelink underscore Euromat. AH SHA H MAC. Then for the ESP, we use AES 256. 25. We have it. No. Okay, so let's just use AES. That's all. Yes, AES. All right, so phase 2 is done on the Afrelink router. Let me copy this. So R3 says 2. Let's call it Euro match underscore Afrilink. AH SHA and ESP AES. That's it. So our next step is to create the interesting traffic that will bring the VPN up. So on R1, that is our interesting traffic, and it's going to be an access list from this source to this destination. Do that configuration here. Let's create that access list on R1. That's it. Access list 150. IP from the source of 192.168.10.0/20 27. Check. 10.0/27 to a destination of 72.160. No, 172.16.10.32/27. 31. Let's verify. Yeah, so to this private IP, that's the destination, 172.16.10.32. Okay. So we have just created an interesting traffic on the Afrilink head end router. So we have to map. Our next step is to map. Crypto map. Let's call it Afri underscore Euro 10. IPSec. Set peer, a remote IP. The public IP of Euromat is 72.160.10.2. 72.160.10.2. That is its peer address. Set transform set. So we copy the transform set that we used on this router. Copy. The match the access control list of 150. So we say, after doing that, we have to come on gigabit interface to apply the map that we just created. So we are going to G0/0 to apply the map. Crypto map. We have applied. So our next step is to come on the Euromat head-end router to do the same. We are going to configure the interesting traffic from this source to this destination by way of access control list. And after that, we will create a crypto map. R3 exit. This is 150. Then it's IP from the source of 172.15.10.32/27 to 192.168 10.0/27. Okay, we just created the access control list. So the next step is to create the crypto map on the Euromat head-end router. Let's call it Euro_Afre. All right, so number 10, IPSec ISACAM set peer. So our remote end will be the public IP address of the Afrelink end. Yeah, so 203.10.0.1. 203.10.0.1. Set transform set. Let's go up to copy our transform set that we created on the Euromat. So we are matching the access control list of 150. At that, we come on gigabit 0/0 on the Euromat router to apply. G00 crypto map. Choose this name. So now we are done with the VPN configuration. So we hope these two PCs here can communicate using their private IP addresses. So I'm going to do something from VPC6 to VPC8. on VPC6, we are pinging 172.16.10.40. VPC6, ping 172.16.10.40. And we are receiving response. So VPN is configured. Let's go back to our question. So our question says, 1, do this by first configuring an IPSec VPN tunnel between Afrilink and Euromat, which we've done, and ensure there is a connection between their private addresses by putting them on a continuous ping. So let's do that. Let me put it on a continuous ping, and everything is working fine. So the next step, is the question. The next step is to configure network address translation on R1. And after we are done with the NAT configs, let's see what will happen to the continuous ping. So the NAT config is going to be done here on R1. That will enable this PC here to have access to the LinkedIn server. On R1, exit. G00 is the outside interface. So interface G00, IP NAT outside. Interface G01, IP NAT inside. IP NAT pool, let's call it internet. Our start IP is 203.10.0 and .1. So we are doing NAT overload 203.10.0.1. So the subnet mask of 255.252. Enter. 203.0.1. Okay. So we just created our NAT pool. Let's configure our access list. 120. Permit. IP from the source of 192.168.10.0/27 to any. So IP NAT inside, if the source qualifies for list 120, pool internet overload. So we just finished configuring the network address translation on R1. And as the question goes, let's check our continuous ping. It's failing. The continuous ping is failing. NAT is configured perfectly on R1, but now the VPN is disconnected. So let's go back to the question. All right, so question 2 says configure NAT on R1 and notice the break in the continuous ping. That is what we are just noticing here. And it goes on to tell us to fix the problem. First, you have to identify the problem and fix it. Why is the VPN breaking? Why is the VPN breaking? Let's see if we can ping the linked in server from VPC6. So from this PC here, we want to connect all the way to this IP address. We know that the VPN connection between the two PCs here, VPC6 and VPC8, are failing. So from here, I'm going to ping 108.174.10.10, and we hope a response. Yes, there's connection. So you solve one problem, you create another one. But we want the two to work. Now we are browsing LinkedIn perfectly, but VPN is failing. So let's make the two work. First, let's identify the problem. Why is it failing? Why is the VPN failing? So let's see how we can identify the problems. On R1, we have two access controllers. One for the VPN. One for VPN. That stays. Permit. This source 192.168 10.0/27 to 172.16.10.32/27. This access list has a number of 150 for the VPN. We also have a second access list, 120, for the network address translation, which is also permitting the source of 192.168 10.0/27 to any. What it means is network address translation will always be checked first. So once this PC here initiates a session to this router, the router is going to check the source. Then apply the NAT settings. Once it checks the source and the source qualifies for 192.168 10.0, the second doesn't matter. It says any, and 172 is part of the any. So this address here is going to be translated to the private address we are seeing here, 203.10.0 and .0.1, sorry. That is why VPN is failing. For VPN, we have to see the public IP address. It doesn't have to be translated. These two devices must see the layer 3 private addresses. They don't need translation. By the moment this PC initiates a session, the NAT policy is always checked first and the address is translating. That is why VPN is failing. So what are we going to do? Now we have identified the problem. How are we going to solve it? We want to deny this address here from being translated. Okay, we want to deny it from being translated. So we come under this access list 120, then we deny 192.168.10.0/27 to a destination of 172.16.10.32/27. So any other address can be translated with the exception of this set of address. So if there is a session between this source and this destination, it has to be denied from being translated. We call this one NAT exempt. NAT exempt. So let's see how we can deny this under this access control list on R1. So R1, do show access list. This access list 120. Okay, so access list 120. Deny the source of 192.168.10.0 to 172.16.10.32/27. Sorry, deny IP. Let's show access list. Do show access list. All right, so we have this list. Let's see if it's solving the problem. VPC. Okay, so let's test. LinkedIn server is pinging. Let's test to see whether the VPN session is up. So we are pinging that private IP address. It's still failing. What must be the problem? All right, it's still failing. So let's go back to R1. Okay, so looking at this access list, the deny must come first. It must be on top of the list. So how do we, this is a numbered access list. We can't modify. Okay, let's see if I can modify. Access list 120. Right. Let me say no access list 120. I've taken it off. So I'm going to bring the deny first. Access list 120. Deny this. Enter. And access list 120 permits this list here. Let's save, check again. So do show access list. All right, so now the deny is on top of the list. Let's see if it works. Okay, now the problem is solved. The VPN is working now. Let's see if we can ping the LinkedIn server. That is also working. So we have solved, we have rectified the problem by using NAT Exempt. Thank you all for watching our video. Kindly follow us on LinkedIn and also on YouTube. Thank you so much.